Okay, guys, so I'll be doing this lecture just for the people that aren't out, didn't show up, or for people that work and stuff, and for people that just weren't paying attention during the time that we did it. We're just gonna go over it. So what you guys are supposed to know on this equation is how to use the ideal gas law and Dalton's law, and get used to using the R constant. That's basically it, and be able to arrange the gas law and solve for different things that's asking. That's basically it. What is the idea? Okay, so this is the ideal gas law. And the only difference that this one has from the other ones is that it uses these two new ones, the N and the R. So the N is going to equal moles, and the R is going to be something called R constant. And if you guys don't already know, this is always going to be 0.0821. You guys don't have to remember this number, but just know that whenever you see R, you have to plug in the number, and it should be this one. Hopefully by now you know that P equals pressure, which is going to be in atmospheres. V is going to be volume, which is going to be in liters. Temperature is going to be in Kelvin. So I already spelled Kelvin wrong. See, I already messed up. T is going to be in Kelvin. So whenever you see Celsius, we don't use Celsius. You have to convert it to Kelvin. And the only way you can convert Celsius to Kelvin is by adding 273. So this is the equation we will use to convert Celsius to Kelvin. So this C is Celsius. And you just add 273 to it. What else you need to know from this? So what you guys need to know from this is that you guys can use the other equations to you can use this equation to come up with the other laws. So Boyle's law looks like this. And that is inversely related, meaning that if one goes up, the other one goes down. So they're the opposite, and the line looks like this, like a J. Anything that is directly related is gonna look like a straight line. And Charles' law looks like this. Do you need to memorize these equations? No. You need to know that Charles' law looks like this? Yeah. You do need to know that the equation looks like that. But do you need to know like all the background information about these? No, you don't need to know that. As long as you know that PV equals PV is Boyle's law, you're good. That's all we need to know. And if you know that it's inversely related, looks like a J, looks like a J is the only one that looks like a J, you are good to go. The other thing that you guys need to know about this is that well, we already went over this, but you can use this ideal gas law, which is this one, the one with the N and the R, to come up with all the other ones, all the other laws, because you can basically pull them out from that one. But that's about it. This we already went over it. But if you don't know that pressure, if you do not know what these letters mean, then you're gonna have issues because you need to know what letters, like what numbers go into it and what units go into there. So whenever you see liters, let's say the question says 33 liters. Obviously, it's gonna go inside the V. If I have something that says atmospheres, whatever number says atmospheres at the end, you're gonna plug it in P. The universal gas constant is always the same number. It's 0.0821. Temperature is gonna be in Kelvin. And I'm gonna write the equation again. And N is just number of moles. So you guys do need to know what the letters mean and what the units are. I'm gonna keep going. And just the same thing, just the units that go in each letter, what the R constant is, what the units are for each letter is still in this PowerPoint. And then the biggest thing that we're having issues with is rearranging the formulas. So for this one, this was also on the review, but if I want to solve for N. So what I have to do is if I want to solve for anything, I have to isolate it. meaning that I have to have it by itself. Why do I have to have it by itself? Because that's what I'm solving for. So whenever whenever someone tells you solve for x, you're gonna have x on one side and then you're gonna have all the numbers on the other side. So it's basically the same idea, but we're not understanding how to do that, which is quite concerning about how much we know about this. So I'm gonna show you guys the formula again. So all these letters are being multiplied by one another, and the only way you can get rid of something that is being multiplied is by dividing. So this is just an example I've used before. So in this one, our x, we want to isolate the x, so we want to have x on one side. So we're solving for x. How do I move something that is being multiplied? I have to do the opposite, which is divide. So I'm going to divide by the 3 on both sides. And then whatever number or whatever like thing that I have on the bottom and the top, it cancels out. So that's why I get x by itself. And then that will be my answer. But on this, we want to isolate or solve for n. So what I have to do is divide by the RT. And then the like units cancel out if they're on top and in the bottom. So the formula will look like this. And that's how I do it. I do not move the PV. I just move the RT to the other side by dividing. You guys do need to know how to do this to be able to solve these problems. This one, it's asking to solve for P. I don't move this side, I just move the V, and the only way I can move it if it's being multiplied by each other is dividing. But we do need to learn how to do this. If you're still having problems in how to do this, then we need to come to tutoring as soon as possible. So the equation for this one will be P equals nRT divided by V. So that will be how to solve for pressure. So if you don't know how to rearrange them, the answers on how to rearrange them are right here. So if whatever question they're asking you, if they're asking you solve for pressure, solve for volume, solve for mole, solve for temperature, this is the way you will rearrange the formula. So you don't have to guess about how to do it. It's already, I gave it to you on the notes. And I'm not gonna do these practice problems. I'm gonna do these other ones that I have. And I'm gonna do these other ones. I don't want to do these because they're already given to you. So I'm gonna pull out these practice problems. And I'm gonna do 2 of them. And hopefully we can learn how to do these. So these are the problems that we did during class. I'm gonna do 1 and 2. So the first thing that I would do is I would write my formula. So this is my ideal gas formula, and I would write what R stands for. So you're gonna plug in numbers for all of these letters, but R is always gonna be 0.0821. So this is your formula. So you're gonna plug stuff in the formula. And then we're gonna do these 2 questions. It says, how many moles of gas does it take to occupy 120 liters at a pressure of 2.3 atmospheres and at a temperature of 340? So first thing you guys gotta do, other than writing the formula, is figure out what they're asking for. So they're asking for number of moles. And based on the formula that I have to isolate or put in by itself on one side. So I have to have in like this. And I have to figure out how to move the formula. The only way I can move these numbers or these letters around is by dividing because they're all being multiplied. So it's gonna look like this. I don't move this because it's already on one side. I just have to move the RT to the other side. And if you don't know how to do this, remember that this is algebra. And we will have to go back to the basics on how to do algebra. So what I'm gonna do is I'm just gonna plug stuff in to the letters. So P is for atmosphere, and my atmosphere is right here. So I'm gonna put 2.3 for P. Volume is in liters, so that's volume. So I'm gonna put 120 for V. R is the R constant, so that's the number up here that we wrote, is 0.0821. And then temperature is here. And you should read the question before you're answering, because it already tells you in the question what it is. So I'm gonna get my calculator if I have it. Yes, I do. So, and then all I have to do is just plug it in the calculator. 2.3 times 120 divided by 0.821 times 340. And my answer was 9.89 moles. So that will be my answer if I'm solving for moles. Next one, if I have a 50-liter container, 50-liter container that holds 45 moles of gas at a temperature of 200. Notice that it tells you 50-liter container. You do have to know this is volume. Already tells you that it's moles, and this tells you that the temperature is 200 degrees Celsius. What is the pressure? So you do need to know what the letters mean, because if you don't know what the letters mean, then you're gonna have issues plugging stuff in the calculator. So first thing is write my formula. And then figure out what we're solving for. So we're solving for pressure. So that means I have to isolate this on one side of the formula. And all I have to do is move the V. So I don't have to move anything else, it's just move the V. And again, if you don't know how to do this, we have to figure something out so you can learn how to move variables. After that, all I have to do is plug stuff in. So N is moles. You need to know what N means. So my number of moles is 45. R is going to be 0.0821. R is a constant, so it never changes. It's going to be constantly the same number. The issue with temperature, we can't use Celsius, so I have to convert it to Kelvin. I have to add 273. So what I'm going to do is I'm going to add 273 to the 200. And it's going to be like, and the answer is going to be 473. And then volume, you need to know that liters is the unit for volume. So I'm going to put liters in the bottom. And all I have to do at the end is just put it in the calculator and solve. So it'll be 45, 0.0821 times 473 divided by 50. And then my answer that I got was 34.95 atmospheres, because we're solving for pressure. So that's basically the gist of how to do it. These are the two examples that we did in class. And most of the issues that you guys are having is moving these variables around. We don't know how to move them around, but the moving the variables around, like I said, we will have to, that's just math. That's just algebra, really, like, to be completely honest about that. So there's a bunch of examples on the Nearpod or on the notes that I didn't really go over. I just told I didn't really think it was that important to go over. This is another example that I can go through. So it says, well, I'll make you guys do this one in class. It says, what is the pressure in atmospheres exerted by a 0.5 mole sample of nitrogen gas in a 10-liter container at 298 atmospheres? 298 Kelvin, I mean. First, write my formula. I need to know that it's PV nRT. And another way I can figure out that is this formula, if you guys were doing a quiz, is that whenever you see moles and they give you moles, it's going to be this formula. It's just, if they give you all this different stuff and it has moles, then you know you got to use this one. You got to rearrange the formula. So we're solving for pressure. So it's gonna look like this. All I have to do is move the V to the other side. So it was gonna look like this. And know that all of them are being multiplied. Except for the V, it's gonna be divided because we moved it. Thirdly, plug it in. That's it. Notice that the temperature is in Kelvin, so we don't have to change it. So I'm gonna do 0.500. Know that that's N. R is gonna be 0.0821. That's our constant. Temperature is gonna be 298. Know that that's Kelvin is temperature, and then volume. Know that volume is in liters. And then all I have to do is multiply these numbers and then divide by the 10. So it'll be 0.500 times 0.0821 times 298 divided by 10 liters. And when you guys are doing this, I wouldn't really use your phone because your phone doesn't know how to. Because if you guys were to put parentheses on this, then it will know what to do first. But because you're just multiplying and dividing, it doesn't really know what to do first. So put parentheses when you guys are doing this. Please put parentheses. So the answer that I got was 1.22 hemispheres. And all I did was multiply these three on top, divided by the 10. Next. This is just another example. We really didn't go over this that much, but this is Avogadro's law. If you guys remember Avogadro's number, it's a really big number. That's 6.022 times 10 to the 23. It's a really big number. And that always has something to do with moles. But here they're talking about volume with moles, and now they have a direct relationship, meaning that every single time volume goes up, which volume is the amount of space. Hopefully you guys know what volume is by now. Volume is like the amount of space something takes up. So obviously if you have a lot of moles, which is an amount, you're gonna have to have more space, more volume. So they're directly related to one another. And then we use N for moles. If you guys wanted to solve for this, it's very similar to the other ones that we've done. So we've had this formula and this formula. And this very similar to this one. This one is let me go back. I already forgot. But remember, you guys don't need to memorize these. You guys don't have to memorize these. We have this one where we have volume on top this time. So it's gonna look like this, and know that every single time we're going to the second one. V1 equals V2 and 1 equals N2. So what I'm gonna do is just put them in the spaces that it should be in this formula. But first I gotta write my formula. Second, highlight the things that are important. So it says 4.8 sample of helium gas contains 0.22 moles of helium. How many additional moles of helium gas must be added to the sample to obtain a volume of 6.4 liters? So what we're solving for is for moles, and they gave us moles of the first one. So they gave us this one, and they gave us volume. But they didn't give us N2. So that's what we're gonna solve for. We're gonna solve for N2. So we don't have that. First thing I'm gonna do is rearrange my formula. This is probably the hardest thing to rearrange because I'll show you why. Because you have to flip the formula. So what I'm gonna have to do is I have to make this be by itself on one side, but I can't do the butterfly method. I can't cross multiply. I can only do it once if I have a number in the bottom, but I don't have a number in the bottom. So I'm gonna have to flip it. And by flip it, I mean everything on top everything on the bottom is gonna go on top, and everything on the bottom, everything on top is gonna go in the bottom. So this is gonna look like this. And now I can cross multiply. So you'll see what I mean. So I'm gonna plug in my numbers. I got 4.8 for volume 1. 4.8, and then I got 0.22 for N1, and then I got 6.4 for volume 2, and then I have a missing number, which is N2. So now you can cross multiply, because notice that the missing number is on top. It's not on the bottom like how it was at the beginning, because I flipped the formula around. So now I can do the cross multiply or the butterfly method, and I can get the answer. And I'm telling you guys, this is all algebra. You just gotta learn how to flip the formulas around. I'm gonna put this in the calculator, and it's gonna give me my answer, which is 0.29 moles. That is how you do that one. Not much going on there. This is just an example problem. And then Dalton's law. The last thing we did was Dalton's law. And Dalton's law is just an addition. It's just them adding stuff together. So Dalton's law is stating that all pressures act independently from each other. So if this was oxygen and this was hydrogen, they will apply their own individual pressure. So it's oxygen, hydrogen. And then pressure is how fast or how many times they collide to the wall. So they're gonna have their own individual thing that they're gonna do. And then if I wanted to figure out the total pressure, all I will have to do is add them together. So that's basically what Dalton's law is. And we're gonna do this example. It says total pressure of 3 gases is 700 torr. So the total is 700. If oxygen is 200 torr and nitrogen is 450, how many torrs of pressure is in the third gas? So all you guys have to do is figure out what the total is, which is 700 torr. Oxygen is 200, and then nitrogen is 450. And then they want us to figure out the third one, which is the missing one, which I'm just gonna write X. So what I have to do is add them together. So it's gonna be 4, 5, 6, 650. And then to figure out the last one, all I have to do is minus them. So you don't have to multiply, you don't have to divide, you just have to do minus 650. And then our answer will be 50. So that's how they got 50 for the answer. And if you guys, we're gonna do the other one, the other example, which the answers are already given. It says the pressure of a mixture of nitrogen and carbon dioxide and oxygen is 150. So that's gonna be their total. It's gonna be 150 total. What is the partial pressure of oxygen if the partial pressures of nitrogen and carbon dioxide are 124? So we want to find the pressure of the last one. So what I'm going to do is I'm going to add 124 together, 124 together, and I get 124. And the total is 150. So all I have to do is minus it, minus both sides. So I can cancel this out, and then I get my answer of 26, which equals X, which X equals oxygen. So that will be the answer. And that's literally it. If you have issues with math, then you need to come to tutoring, because that's mostly I wouldn't really consider this, I consider this more math problems, but we're still having issues with the math involved. If you have issues, with the letters, like what P means, and then what P means, and what T means, and what V means, and what R or N means, then okay, that's different. But if you don't know how to add and subtract, then we need to come to tutoring. But this is just a quick overview of what we did and how to do the questions. But that's about it.